Section 2.8. Our path forward. You've already seen that Copilot can generate code for you. So, can we just ask Copilot to solve our tasks for us? We're afraid not. We still need to learn some essential skills to be able to work effectively with Copilot and to design software that's meaningful to us. To help you appreciate the skills you'll need to learn and to get you excited about where you're headed, we'll give you a larger example that represents what we hope you'll be able to do on your own about halfway through reading and working through this book. Section 2.8.1. How we'll be working with Copilot throughout the book. We'll expand on this workflow in later chapters, but the core elements will be the same. 1. Write a prompt to Copilot using comments, hash, or docstrings, triple quotes. 2. Let Copilot generate code for you. 3. Check to see whether the code is correct by reading through it and by testing. If it works, move to step 1 for the next thing you'd like it to do. If it doesn't work, delete the code from Copilot, go back to step 1, and modify the prompt, and see the remedies shown previously in Table 2.1. Section 2.8.2. Showcasing Copilot's value in a data processing task. For this bigger example, we want you to focus on how we're interacting with the tools and the skills we need. We don't expect you to understand the code until much later in the book. We provide the code solely so you can see what Copilot gave us, but you don't need to try to understand the code in this chapter. You're welcome to follow through this example with us or just read through it. We haven't given you the skills yet to progress if you get stuck, so feel free to wait to work through an example like this until a later chapter. We'll assume for the rest of this section that you'll just be reading along. We want to start with some data processing, as this is something that many of you have likely done in your personal or professional lives. To find a dataset, we went to a great website called Kaggle, which has tons of datasets freely available for use. Many of them include important data such as health statistics for different countries, information to help track the spread of disease, and so on. We're not going to use those because we'd like to have something lighter for our first program. Because both of us are American football fans, we'll play with the National Football League, NFL, Offensive Stats Database. Here's the link to the dataset we found if you want to look into it yourself. See this link. The dataset has NFL information from 2019 to 2022, Figure 2.5.
Figure 2.5. The first few columns and rows of the NFL_offensive_stats.csv dataset.
Step 1. Understanding our dataset. The NFL Offensive Stats.csv file is a comma-separated values, CSV, text file. Refer to Figure 2.5 for a portion of the file. This is a standard format for storing data. It has a header row at the top that explains what's in every column. The way that we, or a computer, know the boundaries between columns is to use commas between cells. Also notice that each row is placed on its own line. Good news, Python has a bunch of tools for reading in CSV files. Let's start by exploring what is stored in this file. To preview the file's contents, you can look at it on the Kaggle webpage under Detail, or Download, and open it in either VS Code or in spreadsheet software such as Microsoft Excel. Don't worry about downloading and using this file just yet. That's for later in the book. However, if you were to download and open it, here's the start of the header, top, row, also shown earlier in Figure 2.5.
See this code?
There are more columns, but these are enough for our first task. We'd like to know which quarterback has done the best over this time period. Step 2. How well did all the quarterbacks do over that time period? If you don't follow American football, that's okay. You don't need to know the game to follow along. Quarterbacks are responsible for throwing the football. We'll start then with looking at how many yards they passed for in that time period. We only want to compare against other quarterbacks because they are the players whose job is to throw the ball. Sure, a running back might throw the ball once a season, and it's often fun when they do. But it's not really their job. To include only the quarterbacks, we'll need to tell Copilot to limit our results to just players whose position, the third column, is QB, stands for quarterback. To solve this task, we created a new Python file called NFL_stats.py and had a conversation with Copilot that you can see in Listing 2.1.
Listing 2.1. Copilot's code to analyze the top quarterbacks.
Notice that we gave Copilot 3 prompts. The first was to handle the input data, the second was to process the data, and the third was to output the response. This cycle of input data, process data, and output data is exceptionally common in programming tasks. If you chose to follow along with us and gave these prompts to Copilot, you might have gotten back different code. That's okay because Copilot is non-deterministic, so it won't always give the same result. However, if it gave you different code, we haven't equipped you with the tools to know if it's correct yet. As such, feel free to just use our code if you'd like to follow along. Reminder: Copilot is non-deterministic. As mentioned in both Chapter 1 and this chapter, Copilot is non-deterministic, so what Copilot gives you may not match what it gives us. This is going to be a challenge for the rest of the book. What do you do if you get a wrong result when we get a right result? We're fairly confident that Copilot will give you a correct answer here, but if you get a wrong answer from Copilot, go ahead and read the remainder of this section rather than working along with Copilot in VS Code. We'll absolutely give you all the tools you need to fix the code when Copilot gives you a wrong answer, but that skill will be taught over the remainder of the book, so we don't want you to get stuck on this now. Looking at the results from Copilot, we have to say this is quite impressive. You don't need to worry about the code yet, but note that writing this code from scratch would be difficult for many new learners. The good news is that anyone can use this powerful tool to do so much more than is possible to do without it. Step 3. Using Copilot to modify the code to exclude one player. We can use Copilot not just to generate new code, but to modify it as well. If we run that code from listing 2.1 on the dataset, here are the first 5 lines from the output.
See this code?
If you follow football, these results shouldn't be a surprise to you. Just to see how well Copilot can adapt to our wishes, let's try to make a minor change. Suppose that because Tom Brady is already recognized as one of the best QBs of all time, you would rather omit him from this comparison. To make this change, we're just going to modify the prompt at the bottom. We went to the point in the code where it says the following.
See this prompt?
We deleted the code, leaving just the comment, and added another line to the docstring.
See this prompt?
Copilot then suggested the following to us.
See this code?
That's exactly what we'd like to see changed in the code. Thanks, Tom Brady, for being a good sport in this example. The code excluded all data for Tom Brady at the point of printing the results. When we save the file and run it again, the first 5 lines now appear like this.
See this code?
Reflecting on the example and the skills we need to write code with Copilot. Without writing any code ourselves, we were able to solve a large, real-world task. However, you still need to learn some essential programming skills. We'll teach you those skills in the upcoming chapters by solving a variety of tasks. By the end of Chapter 7, you'll be able to solve large tasks like these. We want you to take away the following from this example. Copilot is a powerful tool. We didn't write any code ourselves, but we were able to get Copilot to generate the code needed to perform some initial analysis of the data. If you've used spreadsheets, you can probably think of a way to do this using spreadsheet applications such as Microsoft Excel, but it likely wouldn't be as easy as writing code like this. Even if you haven't used spreadsheets before, you've got to admit that it's amazing that writing basic human-readable prompts can produce correct code and output like this. Breaking problems into small tasks is important. For this example, we tried writing this code with just a single large prompt, not shown, or by breaking it into smaller tasks. We found that Copilot was more apt to make mistakes when given one large task rather than multiple smaller tasks. In general, breaking the problem into smaller tasks significantly increases the likelihood of Copilot generating the right code. You'll see how to break down larger problems into smaller tasks throughout the remainder of this book, because this is one of the most important skills you'll need. In fact, the upcoming Chapter 3 will help you start understanding what are considered reasonable tasks to give to Copilot. And Chapter 7 will be dedicated entirely to learning how to break down larger programs into smaller pieces. We still need to understand code to some degree. This is true for several reasons. One is that writing good prompts requires a basic understanding of what computers know and what they don't. We can't just give a prompt to Copilot that says, "Give me the number of passing yards for Tom Brady." Copilot likely wouldn't be able to figure out where the data is stored, the format of the data, which columns correspond to players and passing yards, or that Tom Brady is a player. We had to spell details like that out to Copilot for it to be successful. Another reason has to do with determining whether code from Copilot is reasonable. When the two of us read the response from Copilot, we could determine what the code is doing because we know how to read code. You'll need to be able to do this to some degree, which is why Chapters 4 and 5 are dedicated to reading code. Testing is important. We need to know if the code Copilot gave us is correct or not. When programmers talk about testing, They're referring to the practice of making sure that their code works correctly, even in possibly unexpected circumstances. We didn't spend much time on this piece, other than checking whether Copilot's answer is plausible using estimates on just one dataset. But, in general, we'll need to spend more time on testing because this is a critical part of the code writing process. It likely goes without saying, but errors in code range from embarrassing, if you tell your hardcore NFL fan friend the wrong number of passing yards for a player, to dangerous, if software in a car behaves incorrectly, to costly, if businesses make decisions on wrong analyses. After you've learned how to read code, we have first-hand experience that even if the code looks correct, it might not be. To address this, we must test every piece of code created by Copilot to ensure it does what it should. You'll learn how to rigorously test Copilot's code in later chapters, especially Chapter 6, which is dedicated to the skill. Python is powerful. It's okay if you missed this, but in Listing 2.1, the code imported a module from Python's libraries, import CSV. Python has many built-in tools, called libraries, to help people accomplish their tasks. In this case, it was importing a library to make it easier to read and modify CSV files. We'll harness more of these libraries in later chapters. Python modules. Python modules expand the capability of the programming language. There are many modules in Python, and they can help you do anything from data analysis to creating websites to writing video games. You can recognize when code wants to use a Python module by the import statement in the code. Some modules are built into Python, but there are thousands more that aren't, and that you need to manually install if you want to use them. Chapter 5 will show you how to use modules. In this chapter, we've accomplished a great deal. If you've finished setting up your programming environment and gotten started writing code with Copilot, you should be proud. You've taken a huge step toward writing software. Beyond the details of setting up your environment, you've seen where we're headed by working through an example together. In the examples in this chapter, Copilot gave us the code we wanted without us needing to change the prompt or debug the code to figure out why it's not working properly. That was a nice way to showcase the power of using an AI assistant to program. But you'll often find yourself having to test the code, change the prompts, and sometimes try to understand why the code is wrong. This is the AI assistant programming process that you'll learn more about in upcoming chapters.